So now we're going to suppose we introduce a factor of -1 into each quartic function in step B. So for instance, we're changing x to the fourth to become negative x to the fourth. So how would my answers change? Well, the multiplying by the negative is going to reflect the graph across the x-axis. So the end behavior is going to switch, as well as the max and mins. So what was a maximum value before is going to turn into a minimum value. So we're going to take a look at how to actually sketch these. So first thing we want to do is identify the end behavior. More importantly, I want to look at this equation. I need to figure out what degree it is. So I take a look and I count how many x's there are. There's 1, 2, 3 x's. That means it's degree 3, which has an odd power. So you can use now your little chart we filled out before. It tells us the different end behaviors. Or you can think if it's an odd power, do a normal normal cubic function. What is the end behavior there? But we can see as x goes to positive infinity, f of x goes to positive infinity. Oops, this is supposed to go down here. And as x goes to negative infinity, f of x goes to negative infinity. So we need to identify the graph's intercepts. So we look back at the equation, and we set each of those terms equal to 0. So the first term is x equals 0, and solve it. X plus 2 equals 0, which means that will have an intercept at x equals -2. And x minus 3 equals 0, means that will have an x-intercept at x equals 3. So when we sketch the graph, we need to be really precise about those intercepts where we cross the x-axis. We don't need to be as precise about the y-coordinates, but we need to be really precise about these points where we're crossing the x-axis. So that should always be the first thing you plot, are the intercepts. In this case, we've got at 0, -2, and +3. So now before we start graphing, we need to analyze that end behavior. So if we look back at the end behavior, we graph left to right. So we'll actually look at the bottom statement here first. As x goes to negative infinity, so as we're on the left side of the graph, f of x goes to negative infinity. That means we're going to start low. We're going to start low. We're going to start down to negative infinity. And then our end behavior as we move to the right, as x goes to positive infinity, f of x goes to positive infinity. So we're starting low, but we're going to end high. Now, at our intercepts, we need to determine, will they cross the x-axis, or will they just be tangent? Will they just touch the x-axis? So that depends on the power of each of those intercepts. So all of our intercepts have an odd power, so they will cross the x-axis. So when we graph it, start low, that means we're starting down here. We cross, we cross, we cross, and we make sure we end high. And that's our basic graph. All right, so we want to graph another one. First thing we want to look at, what is the degree on our function? Here we've got 1, 2, 3, 4 x's. That's degree 4, which means it's an even function. However, we're multiplying by that -1, so it is going to be flipped. It's going to be reflected across the x-axis. So we can look at that chart again, or know what this normally looks like. That's the normal x to the fourth-ish. So if we reflect it across the x-axis, it's going to look something like that. So as x goes to positive infinity, as we move to the right, f of x goes to negative infinity. It goes down. As x goes to negative infinity, as we move to the left, f of x goes to negative infinity as well, because it's going down. So we need to find the intercepts. So again, we look at the function. We set each of those terms equal to 0. X minus 4 equals 0 means we'll have an intercept at +4. X minus 1 equals 0 means we'll have an intercept at 1. X plus 1 equals 0 means we'll have an intercept at -1. X plus 2 equals 0 means we'll have an intercept at -2. So those are the 4 key things I really need to be careful about plotting on my graph. Intercepts at 4, 1, -1, and -2. So now we use the end behavior to help us figure out what the graph's going to look like. Notice, again, as we either direction we go, right or left, we're going down to negative infinity. So we're going to start low, and we're going to end low. Taking a look at our intercepts to see whether we're going to cross or be tangent to the x-axis. All of these intercepts have a power of 1, which means they all have an odd power, which means they will cross. You're going to cross the x-axis. So we have to make sure we start low. So we're going to start down here. We're going to cross, 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 and we're ending low. That's what we wanted. So it's going to look something like that. And let's try one more. So first thing we need to recognize, what's the degree on our function? Now this one's a little bit different. We've got an x squared and an x, so that makes 3 x's, degree 3, which is an odd degree. And we're multiplying by that -1, so we're going to be flipped again, reflected across the x-axis. So end behavior is going to be opposite than normal for an odd function. So as x goes to positive infinity, f of x is going to go to negative infinity. And as x goes to negative infinity, f of x is going to go to positive infinity. All right, what are the intercepts? We look at each of our terms, set them equal to 0. X squared equals 0 means we'll have an intercept at x equals 0. And x minus 4 equals 0 means we'll have an intercept at x equals 4. So those are our two intercepts. Those are the two really important things we need for our graph. So now we're going to use our end behavior to figure out what's going to happen. So again, we're working left to right, so we want to actually look here first. So as x goes to negative infinity, as we're on the left side of our graph, f of x goes to positive infinity, so that means we're going to start high. And as we move to the right, as x goes to positive infinity, f of x goes to negative infinity, so we're going to end low. Taking a look at our intercepts, again, it all depends on the power. So because we have one term that x squared equals 0, that means it's going to be tangent. If we've got an even power, it's going to be tangent. So we're tangent at 0, don't cross, because it's got an even power. But our other intercept, x minus 4, we will cross that because it has an odd power. It's got a power of 1. So we're going to start high. We're going to start high. We're going to touch the x-axis but not cross it. I'm going to cross that 4 and we're going to end low. And so our graph is going to look something like that.